Folding. Protein folding can be described like a chemical equilibrium, where we think of ourselves as converting from unfolded protein chains to folded protein chains in sort of a one-step reaction. There are no intermediates. For simplicity, we just imagine we're either unfolded or folded. And so we can write our equation kind of maybe two different ways. We could have the folding reaction would be going from unfolded to folded. I think I have a slide that shows this as D to N for denatured to native state. And I might also link you to things that show it that way. So just maybe unfolded would be denatured. Native state would be the folded state. Like it wants to be folded. So then I could write a equilibrium constant, K of the folding reaction, as the concentration of the products, so the concentration of folded over the concentration of unfolded. And so again, the way to think about this sort of physically in some solution of protein is that I have some amount of them unfolded and some folded, and those are the only two options. Okay? Alternatively, the unfolding reaction would be going from folded to unfolded. K for unfolding, really pay attention to your subscripts or what you're being asked for here, would be concentration that's unfolded over folded. It's also 1 over K folding. Okay? So if I want to think, remember now for equilibrium constants, that has a relationship to standard state free energy change. For a reaction or actual observed free energy change, we would be talking about reaction quotient. Okay, so looking at our basic standard state Gibbs reaction equation, and then let's talk about the folding reaction forward. Is this spontaneous? In real life, in the body, yes or no? Yes, yeah, hopefully, or you're dying. What is the sign of delta G? Negative. What is the sign of delta S? Negative for folding. So before we were saying, oh, if we unfold it in a calorimeter, it would be positive, right? So this is where you really want to keep track of, am I folding or unfolding? Okay. The sign of delta S in this case would be negative. What do I expect the sign of delta H to be when I fold? Negative Y. I agree with you, but why? Okay, so it has to be, because if I'm going to make delta G negative, this is a negative, subtracting a negative is a positive number. This better be negative by a lot in order for me to keep this. I'm forming a lot of interactions. What kind of interactions am I making when I fold it up? Exam 1. I could make some H bonds, I could make some van der Waals, I might make a salt bridge, I could make a disulfide, something. Yes, when I fold it up, the protein can make some interactions with itself, and I would maybe expect my delta H term to be negative. Do you want me to spoil what's going to happen? Or do you just want to wait and see? This is going to be a positive number. This is going to be a negative number. And I'm going to tell you that this is still negative. And it's going to be because right now I'm talking exclusively about what the protein is doing. And the answer to everything in this class is we ignored the water. Okay? We're going to talk only about proteins. And then when we add the water in, we will see what happens to actually drive this thing to be negative. Okay? Switch back to the doc here.